Good morning, all my subscribers. Today I have a very interesting project here. I always thought about when you have a dish, some sort of dish of what transmits signals. how does the how do they know how to design the parabol or the size of the dish or the shape of the dish, so wherever your transmitter or receiver sits, that it can reflect the signal parallel or to the desired place. And then I took one of these, I think as I use it at home, if you have a business and close by from your home, and then you stream maybe your internet line or whatever business line there is to a close proximity, and other side you receive it, or maybe there's a bad signal. What I did is I marked the half of the dish in the middle, and then I put a piece of carton here and supported by a piece of wood here. This is glued on here. And then I draw parallel lines, but I'm just going to fasten the thing in my workbench here. So I can work with it. And then what next is, then I thought about putting a green laser pointer. See, here's your laser pointer. And then if I use it at the same size of the source where the transmitter is, and then I move it along, and then we will be able to see how this dish reflect the signals or the transmits the signals in a parallel wave outside, and not skew or in a narrow band or whatever. So how this thing works here is here's a transmitter here. I opened it. This is like an internet cable you can put in here, and then there's a PCB inside here. So there's all the electronics, and then there's the signal or the points where they transmit. There's little pins. Someone put their solder on there, but there's different sizes. So I think this is how the frequency is tuned, or quarter wavelength or whatever. And then in the correct place, and this is where the signal gets transmitted and then bounced on this thing. But if you look inside the front piece, there is like a metal part here. It's like a bended metal plate. Obviously this sits in front here, and this reflects the signals this from here to here, and then back to your dish, and then out. So maybe one is the receive side, one is the transmit side, or both, maybe a dual signal or white band. I don't know what the difference is, and I'm not a RF boffin. Okay, but then this goes in here. This PC board goes then inside this unit here, and I just put it back in here where it belongs. And then this thing goes in there. Then obviously it sits here. Now I marked the distance from here, from the point where it sits in the back there, and I found the point is just there, where it transmit, where this metal part sits just there. And from there you'll see the angles. It goes here all over the place. Okay, now this is how this thing looks. Now let's get back. Now what I did, I put some holes in here. That where the black mark is the one exactly where that transmitter the signals from, and I put my laser pointer, put a disc and a screw, and where the screw is exactly inside where the laser diode is. So then it will be exactly. Now let's start. If you press the button, what I did, I'm just going to use this glasses by using my laser cutter just for my eyes. I don't damage my eyes for the laser. And then if you then switch on the laser, look what's happening. Now I put some aluminum foil here from the kitchen, using kitchen just to reflect, to get a nice shiny surface. Now if you push the button, you can see what's happening here. If you just put the angle right, you can see the angle of the green. Sometimes it moves, but this fully is not perfectly straight. But you can see what I get to. So you can see how the lines get perfectly reflect parallel with the lines. Now you can see how this is actually working. This is very, very cool, if I say myself. And now what I did, I thought about, let's make a mark closer. If it's closer to the, if the design is not correct, then it will reflect outwards. It's not parallel. And this is exactly what's happening here. You can see, you can more or less see what's happening here. It's not parallel anymore. This line is not parallel. It goes skew. So your signal, if you have your design is not correct, you won't go very far with this amount of signal strength that goes out here. It will diminish it. This is also very cool. And then, now if I use it further away, let's make one further. So if it's further, then I would say it will go maybe wider or closer. Let's see what's happening. See, it goes inside. Then the reflection is inside. You can see here, it goes like this. It's not parallel anymore. So when the further you go from the center point, it goes in the inside. The closer it goes on the outside. So it shows you how important is the design of this dish. And the DSTV of the satellite dishes, where the your signal, the receiver sits a little bit on the bottom side, then the signal goes in, and the design is like this. It goes and it bounces all to one point. And this is how important it is that you get the correct dish, or your design of the dish. If you're a designer, if you're an RF guy, you design your dish. But I guess there's software that does all this for you. This is very cool. So you can try it yourself. You want to make an experiment. And as I say, in the middle is exactly where more or less I thought this would be. And it shows you the lines is very, very, very parallel. It looks like the design is correct. So I guess if you take this transmitter and you should put a mechanism that you can screw it in and out, and then in a factory just tune it for the most parallel, most maximum signal on the other side. Okay, this is how a satellite dish is working. I just want to make sure you guys, maybe I'm just switch off the light. It's a little bit darker here, then we can see better. Okay, what I did, I switched off my workroom light, and now you can see so much better. You can see how this goes parallel. And if you go, let's go closer again, you can see it looks like the signals is a little bit more outward. And if you go in the outside, the signal goes in the inside. You can see it. This is very clear. You can almost see how the thing goes more to the center. So this is a very cool experiment. This, as I say, be careful if you play with your laser. Be careful, just protect your eyes. And so this was my experiment for today. And this was very cool experiment. I hope you enjoy it. Don't forget to subscribe and thumbs up what you think of it. Until next time, cheers.